Okay, person of mass 64 kilograms is standing in a lift which is of mass m kilograms. When the lift is accelerating downwards at a constant rate of 0.425 meters per second squared, the tension in the lift cable is 7,500 newtons. Part A then says calculate the value of m. Now we're looking at the lift forces as a whole, right? So we're appreciating then the weight here we've got is not just the lift, right? Because it says the lift is of mass m kilograms. We've also got a person standing in the lift of 64 kilograms. So what we need to do is, of course, is add those masses together, yeah? The mass of the lift, which is m, and the mass of the person, which is 64. So you add them together to get the total mass. Okay, if you want, you could have written that before. Total mass equals the mass of the lift plus the mass of the person. So you get that, right? M plus 64 kilograms. Of course, to get the weight then, you've got to times it by gravity. And then you've got the tension then going upwards, 7,500 newtons. And then we've got our acceleration downwards, isn't it? So what we do then is, part A, to find m, we say, look, using Newton's second law in the direction of motion. Okay, so that will be then, this will be the leading force, won't it? Because we're going downwards. So m plus 64 g. Take away then the tension, because it's going the opposing way, 7,500. Okay, so it's sort of pulling it back, isn't it? And that will equal then the mass, which is m plus 64, times then the acceleration, which is 0.425. So you've got yourself an equation here, which will enable us then to work out m. Okay, so I will basically times that now by 9.8, so I'll have 9.8 m. Okay, so remember now that's 9.8, so 9.8 times m, and then 9.8 times 64, and we get 627.2. Take away 7,500, and then that will equal then 0.425 m plus then, by times by 0.425, 64 as well, I get 27.2, so I can't quite fit that in, so I'll write it there. Okay, so what we'll do then is, maybe we'll tidy this left-hand side up a little bit. 9.8 m, 627.2, take away 7,500, so I get minus 6872.8 equals 0.425 m plus 27.2. Get the m's onto one side, get the numbers onto the other side. So 9.8, take away 0.425 is going to be 9.375 m. On the other side then, 27.2, add 6872.8, so I get 6,900. And of course to get m then, we need to just take that over and divide. 6900 divide by 9.375, and I get out exactly 736. Okay, that's my value of m there. So a lot of work, but if you set up your equations properly, you'll get to the answer. Okay. Part B then, it says find the reaction between the person and the floor of the lift. So now we've got to zoom in, right, onto the internal forces. Okay, so another diagram is needed, and then the person we consider, of course, we need to use the mass of that person, okay, which is 64 kilograms. Okay, so we label the person as a doctor, right? So 64 kilograms. So then the weight will be 64g, and I want the reaction. Okay, now remember it is accelerating downwards, so we know acceleration is 0.425. Okay, so then again we use Newton's second law, okay, to focus on these internal forces in the direction of motion. So we've got 64g going downwards. Take away then the resistance, which is R, or the reaction. It's the force that's going the opposite direction of motion. So 64g is the leading force. Take away R, that will equal then the mass of that person, which is 64, times the acceleration, which is this. Now remember, we're only focusing on that person, not the lift. Now we're just looking at what's happening to that person, and that person is accelerating downwards. That person is accelerating downwards at that rate of acceleration. Okay, So that's why we use the master of that personal loan. So if we work out then 64 times 9.8, and we get 627.2. Take away R equals 64 then times 0.425. So we get 27.2. And then all you're going to do is take that over, and then you get your R to be 627.2. Take away 27.2. So R will actually equal to 600 newtons. Spot on, yeah? Brilliant.